Alright guys, I sincerely hope you're not watching this video because this is a pretty standard equilibrium question that happened to appear at the very end of that midterm. Here we got PCl5 in equilibrium with PCl3 and Cl2. They're all gases. And at 250 degrees, we start with a certain concentration of PCl5. They give us the Kc and they want the equilibrium concentrations. They gave us initial, they want equilibrium, boom, ice table. So, PCl5, PCl3, Cl2. Start with 0.125 of these, and none of those. Lose some of that, gain some of those. Equilibrium concentrations are 0.125 minus x, x, and x. Our K, EQ, or in this case Kc, is PCl3 times Cl2 all over PCl5, where these are equilibrium concentrations. In this case, we have 1.8 equals x times x all over 0.125 minus x. Ah, now I know why this was at the end of the test. This K is not small enough for us to assume that x is insignificant here, which means we're probably going to need the quadratic formula. I'm going to move my 0.125 minus x over to the other side, and I'm going to have to multiply that 1.8 through. Let's do that quickly. 1.8 times 0.125 gives me 0.225 minus 1.8x equals my x squared. And so if I move everything to the right-hand side, I end up, oh, I forgot my x. I end up with this quadratic equation that can only be solved with the quadratic formula. Who likes the quadratic formula? I certainly do. Let's do this. When you have everything on one side, and it's in standard form where you have something x squared plus or minus something else x plus or minus something else, and it's equal to 0, you can solve for x with negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, my a is 1. There's nothing in front of my x squared. My b is 1.8, and my c is negative 0.225. So let's plug these numbers in. Negative 1.8 plus or minus the square root of 1.8 squared minus 4 times 1 times negative 0.225 all over 2 times 1. It's negative 1.8 plus or minus the square root of. I'm going to do this all at once. 1.8 squared minus 4 times 1 times 0.225 negative. And and that's the number that goes in here. 4.14 all over 2. Alright, now I can get these two numbers. Negative 1.8 plus square root of 4.14 all divided by 2. 0.117. Let's check the other one just to make sure it's not going to give us another okay answer. 1.8 negative minus square root of 4.14 divided by 2. Oh yeah, see? 1.92. Not only is 1.92 bigger than the initial concentration at all, but it's also negative. And you can't lose a negative amount of this stuff. So that one's no good. X must be 0.117. And so our equilibrium concentrations are, for PCl5, 0.125 minus 0.117. See? That minus x, and x to 0.117. 0.008, apparently. And for PCl3 and Cl2, the equilibrium concentration was whatever x turned out to be, which is 0.117 moles per liter. Sweet. And there's your answers. Now I'm just going to do a little experiment here, see if I get the right answer when I plug these numbers back in. 0.117 times 0.117. See, I'm using my formula here. Divided by PCl5, which is 0.008. I get almost 1.8, which was the original answer. Now, the reason it's off here is because I ended up doing some significant rounding here that I probably shouldn't have done, but whatever, sue me. Point was, it was a standard equilibrium question, do an ice table, but if your k is not small enough, you're going to have to use the quadratic formula to solve for x and get your equilibrium concentrations from there. Best of luck.